Hey guys, today we are going to go ahead and finish up section 8.3. So we are going on to the third part, which focuses on something called continuously compounded. Now part 2, we looked at something called compound interest. And with compound interest, there are a variety or a various amount of times that the bank can add interest to your account. Remember, we had yearly means 1 time, semi-annually means 2 times. Quarterly is 4 times. Monthly is 12 times. If you have interest added daily during the year, that's 365 times. Okay, but now today they're saying, well, when interest is calculated as if an infinite number of compounding periods occur each year. So that means it never really stops. So it's like every hour, every minute, every second. And when that happens, when they are just continuously adding money into your account, that's when they say it's continuously compounded. Well, in order to calculate a balance for this type of account, we need a new formula. You may have heard of the PERT formula before, and that's what this is. P is the principal. That's the same as the second part of 8.3. The principal is the amount that you initially invest. Now E, you guys, E is a number. E is just like pi. Pi is 3.14. And I is the square root of a -1. E has a numerical value. It's approximately 2.71828. And in order to calculate a balance that is continuously compounded, we need to use this number. Then E is the base, meaning R and T are its exponent. R is your interest rate. Again, that's a percentage. Make sure you turn it into a decimal. T is time in years, okay? So A, what they're saying that it equals, that's your final amount, that's your balance. So again, how much money did you invest? The number E is a base. Take your interest rate as a decimal, multiply it by your time in years, and you're done. The formula for continuously compounding interest contains the number E. So again, just like pi and I, the number E is denoted by a letter, but it is a number. Kind of cool. The number E is called the natural base. Okay, the value of E is approximately 2.71828. Okay, let's go ahead and do some calculations, guys. It says you deposit $500 into an account. It pays 4% annual interest, compounded continuously. When it's continuously, that's when you use the PERT formula that we are learning today, okay? So you deposit 500, that's your principal. E to the power of your interest rate, 0.04, times the number of years, that's a 1. So if I multiply those together, I would have the 500 E to the 0.04. Now, E is a value in your calculator, okay? If you look on my calculator, I have the yellow options. You'll see E. I have this natural log key, which is ln. Above that, you'll see E to the power of X. That's how you're going to get the E. So I have to hit second ln, and then it will give me that yellow option. So let's go ahead and enter this into the calculator. So 500, that's my principal. Second ln. Now it's E. E is always a base. That's why it automatically says E to the power of what? And then in parentheses, what is the exponent on E? 0.04, close it, because that means that we are done with the exponent. My $500 is $520.41. Remember, we are rounding to money. So this is 405. This 5 would bump it up to a 1, and you're done. So if you had this scenario and you were investing your money, after just 1 year, your $500 is now $520.41. Find the balance after 11. So, okay, what happens if you put 500 in, E to the 0.04, because it's 4% interest, times the amount of years? Let's turn this into one number. So it's 500E 0.04 times 11. My exponent is 0.44. So I start off with $500. Second ln, my base is E because it's continuously compounded. 0.44. Your $500 now is $776.35. So it's very similar to what you did with the second part of 8.3. You are just reading a scenario, filling in the values into your formula, entering it into the calculator. But it's really cool because now you learned a new number, you learned E, and you learned how to calculate something that is continuously compounded using the PERT formula. 2 more examples, and that'll be it for our video today, guys. Let's say you deposit $1,000 into an account. It pays 3% annual interest, compounded continuously. That means it's the PERT formula, okay? Find the balance after 3 years. So P, the principal, you're investing $1,000. E is your base because it's continuous. Your interest rate, 3%, is 0.03 times how many years? So I'm going to go ahead and multiply this so I know what my exponent is. 0.03 times 3 is 0.09. 0.09, enter that into your calculator. So 1,000. To get E, it's second ln. My exponent is 0.09. Close it. Your $1,000 after 3 years is now $1,094.17. And that's your answer. Well, they're saying, okay, well, let's say you go there at 3 years and they're like, okay, this is your balance. You decide to not take it out and you wait 2 more years. So what would the balance be after 5 total? So 1,000 e to the 0.03, because that's the interest rate. You left it in the bank for 5 years. So 1,000 e, turn this into one exponent, so 0.03 times your 5 years is your 0.15. Now go ahead, enter that into the calculator. So 1,000 second ln, your base is e, to the power of 0.15. So if you decided to leave that money in for 5 years, $1,161.83. Let's look at one more, guys. You deposit $725 in an account. This account is paying you a much higher interest rate, you guys. We're looking at 6.25%. Okay, that's really good. Compounded continuously, PERT. Find the balance after 7 years. So you put $725 in e to the 0.0625. Remember, you always have to move the decimal to the left 2 places. Times how many years are you keeping it in there? They're saying you put that 725 in, you did not touch it for 7 years. So I have 725 e to the, let's go ahead and multiply, 0.0625, that's my percentage rate, times 7 years. My exponent is 0.4375. Enter that into the calculator. So 725, there's your principal. Second ln, you get e to the exponent of 0.4375. Your $725 is now $1,122.90. The reason why it grew so much faster than like the previous example, it's because your interest rate is higher. The higher your interest rate, the more money you're going to be making. Let's say that you went back 7 years later and you were like, oh my gosh, that's a lot of money. I think I can keep it in there for 5 more years, meaning it's been in there for 12 years. Then you go back and take that money out. How much would you have? So you brought $725 into the bank. E, your interest rate is 0.0625. You left that money in the bank for 12 years. So we have to turn this into one exponent. 725 e to the 0.0625 times 12. 0.75. So 0.75. Now let's go ahead and see how much money we would have. 725 times e to the power of 0.75. Your $725, you guys, it's $1,534.83. That is an awesome investment. Way better than like taking your money, putting it in an envelope and hiding it in your freezer or something. This is the reason why you should always check out investments as you get older and invest that money. You can make money by just having somebody else hold it for you. Super cool. I hope you guys enjoyed 8.3. It's kind of fun to look at that real life math stuff. I will talk to you all soon. Take care.